So if we consider one point in a continuum, and we are interested in the forces exerted within the continuum at this point, then we need to define a surface with a certain orientation. And we can define the stress vector, so the force exerted by the continuum on this side of the surface upon the continuum which is on the other side of the surface. We can define it with the Cauchy stress tensor, and we write that the stress vector T, which is a function of position, time, and the normal vector, is going to be equal to the stress vector at this location as time times the normal vector. So is this mathematical formalism consistent with Newton's third law? Okay, so if we retake this example, so we have this point in our flow and we are asking what is the force exerted in the continuum. We've defined our surface. Now we need to decide, we are looking at the force exerted by what on what. So we need to define a control volume. Let's say this is my control volume, and what is inside my control volume here I will call 1, and what is on the outside I will call 2. And so here clearly we are looking at the force exerted by 2 onto 1, and this is equal to here our stress vector at our position x and t and at the normal n. But now, of course, given the same surface ds, I may want to look the other way around. And instead of looking at the force exerted by 2 onto 1, I may want to look at the force exerted by 1 onto 2. So that would be if I now looked at this different control volume, which would be like this, for instance. Right? In that case, our vector pointing outside of our control volume would be pointing in the opposite direction. And so if I keep these notation, this vector would be minus the previous one. So let me call this vector n2 onto 1, and this is n1 onto 2, and that would be equal to minus n2 onto 1. So I'm now looking at this control volume, and I'm looking at the force exerted by 1 onto 2. And this force here is equal to the stress vector at x and t, but at the normal vector n, which is equal to n1 onto 2. And here that was n2 onto 1. And so if our tensor notation, so if the Cauchy stress tensor is consistent with Newton's third law, we should have that this stress vector here is opposite to this stress vector here. So is the force exerted by 2 onto 1 equal to minus the force exerted by 1 onto 2. Now this is simple enough to verify. The force exerted by 2 onto 1 is simply equal to the normal vector times the stress tensor. But of course, the normal vector n2 to 1 is equal to minus the normal vector n1 onto 2. And therefore this is equal to minus the normal vector of 1 onto 2 times the stress tensor. And this here is, by definition, the stress vector for the normal vector n from 1 onto 2. So this is then equal to minus the stress vector. So therefore the force exerted by 1 onto 2. Right, so this formalism here, so we have this inequality, right? We have this equals to minus that, and therefore the formalism of Cauchy's stress tensor is in agreement with Newton's third law.